Very good afternoon to all of you. I welcome you all to the technical session 5, that is the papers by the industry. And for this, I would like to call upon our chairman, Shri S.K. Malik, ex-additional member, Railway Board. And for this, I would request Shri S.K. Gupta, CBE, Central Railway, to kindly escort our chairman, Shri S.K. Malik sir. Also, midst of us, we have a co-chairman, Shri H.S. Yadav, ex-CAOC, NF Railway. And I request Shri D.K. Chandrakar, CETB, Central Railway, to kindly escort our co-chairman, Shri H.S. Yadav sir. Alright, so before we begin, let me tell you, we have total of 5 papers in this technical session. So before we begin, I request a respected chairman and co-chairman to kindly give away the opening remarks.
Respected Chairman Sir, Chief Guest AM Civil Engineering, dignitaries, authors and speakers here, good afternoon to you all. In fact, this is the last technical session and it will be presented by the industry. And we have limited time, so I will request to go straight for presentation, and rest other things we will talk at the end of the presentation while summing up.
10 minutes for each.
And 10 minutes are allotted for each presentation. So I will request all these speakers to kindly abide by the time because we are already running slightly late. Thank you very much. Kindly, speakers may kindly take their seat here.
We already said that it will be 10 minutes for each. So the first paper.
Alright, before we begin, we have volunteers in the audience. So simply raise your hands to pen down the questions and then we shall pass it on to the concerned author. Alright, so let's begin with the presentation of the papers. And the first title of the paper is Pandrol Modern Track Solution for Indian Railways. And for this, I would like to call upon Mr. Sashikant Mishra, Associate Vice President, Pandrol.
Good afternoon, everyone. Good afternoon to all the dignitaries here and all the esteemed attendees for this August session. And thank you to IPWE and IRSEN for giving me this opportunity to speak here against this beautiful gathering in the post-lunch session. I am Shashikant Mishra, and I am the Technical Director at Pandrol Rahi Technologies. And I'll be presenting a presentation on modern track solutions for Indian Railways. So I have a longish ride to take you along on. So this will be a little high-speed adventure. It'll be really fast. I'll show you all the solutions, what we are offering towards Indian Railways modern infrastructure. And we also have a stall outside in the technical exhibition grounds. You are more than welcome to visit to see all the solutions here in live form in the exhibition out there. So here we go. We have a string of solutions to offer in ballastless and ballasted track solutions, in fastening, in track solutions, and in equipment. Pandrol, as you know, has been a driving force in the rail industry. We have a world speed record of 575 kilometers. We have the longest heavy haul track, and we have the world highest track in Tibet. These are the areas and domains that we offer our solutions into, starting with fastening, for which we are traditionally known as, but we have many more domains like ATW welding, we have electrification, we have sustainable resilient systems, and we have condition monitoring, track equipment, and we have track control solutions. These are a few of the partners globally, India and overseas, that we have supplied our solutions and offered our services to. The first solution that we are showing here today is the embedded rail system QTrack. QTrack also stands for QuiTrack, but primarily it's an embedded rail system. So here in this picture, you can see that there's a tunnel, there's a track, and it's a train track, but a car is also plying on the same track. So this concept can be utilized in hybrid tunnels in the mountains where the same track can be used for vehicular traffic as well as rail traffic. Now, this is a continuously supported and enclad embedded rail system where, because of its, the rails are completely clad, the stresses in the rail are far reduced, and there are no fasteners, so there is absolutely no chance of corrosion here. And the rail, because it's continuously supported, the stresses are low, there are no sleepers here, so there are basically no additional components for fastening the rail to the track. It is just this embedded rail system. Here again a picture from Portugal, in Tunnel do Rossio, for 120 kmph design speed and 22-ton axle load. Has been operational since 2008. The system is proven for 160 kmph and higher the speeds. A Mirfa depot in Etihad Rail. So these are the solutions that we can use this system for hybrid tunnels, for depots. This we have done in Delhi, in DMRC Badli depot. For 1 kilometer track we have laid. This could be used in modern stations to have a very clean look for the track. And this picture is from the Makkah Medina line, Haraman high-speed rail speed station. Maintenance with QTrack, maintenance is far reduced because of the lower stresses. Rail corrugations are far reduced. And the absence of stip points, there are no direct fasteners here. The rail is continuously supported. And the cleaning on the track is very easy. It can be done very easily with the mechanized cleaning. This system offers one of the thinnest ballastless track, which can be utilized in the tunnels where you have very less height available. And because in tunnels, if you put a ballasted track, it can take substantial height of the track. So this system forms one of the thinnest track, ballastless track in tunnels. Advantages, it's a maintenance-free solution. It's free from corrosion. There's no theft, no sabotage, no prone to any vandalism for the fastening components. Rails are encapsulated, so there is some kind of vibration isolation also available because we are lowering the stiffness of the entire track by putting this solution into. And the possibility of rail fracture is greatly reduced because of lower stresses in the rail. And it has a very very high longitudinal rail restraint, the creep resistance, because the rails are continuously enclad in these rubber profiles. And it can be used both for vehicular traffic as well as for rail traffic. The second system is the booted block system. Now, this system we have used in the US BRL project for almost 70 kilometers of track. More than half we have already done. The work is still going on. So we have installed this system in the tunnels, on the bridge, and on viaduct, on embankment as well. So there are all the uses that we have done. These are some beautiful pictures from the mountains in Kashmir, where this system has been installed. The anchors are being installed using a torque tightener here. So look at the system. This is an ideal ballastless track system. Basically, what we are doing here, because it's a ballastless track, there's no ballast. So in the resilience of ballast, which is gone missing, we have introduced with this booted block here. And if you look at the distinctive features of the system, this system is the closest and best idealization of ballasted track by virtue of offering a precast rail seat coupled with required resilience and adjustability as obtained otherwise in ballasted track. Booted block system offers the required flexibility to accommodate cyclical loads and deflections and caters to the performance requirements with minimum vertical deflection by virtue of having a resilient booted slipper pad under the concrete block. We'll look into the components in the next picture. Delamination between precast and in-situ concrete under cyclical dynamic loads has been a perennial problem. We have seen multiple failures on that front. This system with a rubber boot separating the precast concrete block from the in-situ concrete acknowledges this, and its long-term proven performance substantiates that the concept is the right solution to avoid such delamination between the precast and the cast in-situ concrete if they are juxtaposed against each other without any rubber layer in between. So here, the rubber boot provides that benefit. Look at the component. At the bottom, you can see the rubber boot, and then there is a booted sleeper pad, which is a resilient pad inside the boot and between the precast concrete block and the boot. And then there are dowels, the screws which go inside the dowels, the rail pad, the angle guide plate to provide that lateral support to the clip, to the fasteners, and the rail. Those are the dimensions of the booted block system. And the weight of this block is 90 to 95 kg. So it's pretty light and can be easily managed by 2 people on site. Quick and easy installation is one of the benefits. System stiffness can vary from 10 to 50 kilonewton per meter. And an elastic pad can be varied to bring down this stiffness, and the stiffness can be varied by changing this resilient pad inside the boot. It's a climate-ready solution. It can be used in high humidity conditions also. And this system has been in use for the last 25 years at 200 kmph and 22-ton axle load provenness. And with USBRL, we'll have more provenness for 25-ton axle load as well. Having said that, the system is tested for category C loading as per EN standards, which is for 26-ton axle load. And this also provides some vibration mitigation, noise and vibration mitigation, so it can be utilized in tunnels where there is sensitive geography. It is simple to maintain and has an ergonomic design. It has been tested. Here's a table which shows that the system is tested as per category C. C is 26 ton and 150 curve radius. So this is what the system has been tested for. And the fatigue cycles are 3 million, and that the system has been tested for. We look at the installation. The blocks are placed. The rails are placed on the block, and this track can be also used for moving of, as a temporary track for material movement also. The jigs are introduced. The rails are, along with blocks, are lifted and inclination and gauge adjusted. Reinforcement as per approved design is placed. The concrete is poured. Once the blocks are adjusted and handled to the current, and the track is ready. So it's very simple, very easy to construct, given that it's all pre-assembled block, and it can be brought on site, hung from the rails, and it can be cast. These are some of the projects. Looking into ballasted track solutions, we have undersleeper pad and under ballast mat. These are, again, solutions which can provide resilience into the track. One UIC study says that you can remove 100 millimeter of ballast from the track by introducing these solutions. And by deploying these solutions, you can have reduction in ballast thickness, long pitch rail corrugation, and airborne and groundborne noise. Maintenance reduction, frequency of leveling, lining, and tamping is reduced. Rail corrugations are reduced. This material, this USP, has been tested for 36 million cycles, which is a French vibrogate test which is done on this material, and it has passed successfully with having a variation in sleeper weight of only 0.1%, and the stiffness variation is less than 4%. So it performs beautifully with that high fatigue cycles also of 36 million cycles. These are some of the partners that we have worked with. I'll skip this. This is the benefit of UBM, vibration mitigation, and in stiffness transition, it can be utilized. And in India also, it's being put on track for stiffness transition between the embankment track and the bridge track. The fastening solution for ballasted track, FE, it's a simple pre-assembled system which comes on a sleeper, and it's a unique switch-on switch off kind of system where it just...
Will you please expedite?
Yes, sir. Switch on and switch off. So it comes in park position like this on the sleeper, and you just have to push the clips from both sides to put in the install condition. It facilitates mechanized clip installation. It has reduced lifecycle cost. It maximizes uptime. One major benefit is mechanization is possible, and the system comes fully pre-assembled on the sleeper, which makes installation far quicker. These are some of the examples. RE, this is a good linerless fastening solution, which can be utilized on existing sleepers, where you have just these two components, and both have integrated liners onto them, insulators onto them. And with just these two components, you can retrofit your track, make its life much longer, 30, almost 30 years increase in life.
Wrap up.
Yeah.
Kindly wrap up, please.
So, these are some advantages. This is a screwed fastening, which can be retrofitted on System 300. It also comes pre-assembled. It has a very compact design, and it's environment-friendly and quite adjustable fastening solution. These are a few applications for heavy haul. This is another fast clip-based solution. It can be used as on a ballastless track, and it can be switched on between different solutions on the same sleeper for having lower stiffness. This is VERSE. This is a stress-free temperature measurement device, which is it can measure stress-free temperature for any given track. It stands for vertical rail stiffness equipment. It's a non-destructive method of measuring stress-free temperature of CWR, and it's a recognized standard for measuring risk of track buckles and rail breaks. It can be used as a routine survey tool and as a spot check, as a quality control tool as well. This is just theory. You all are familiar how we measure this SFT by just utilizing the stress strain formula, by giving a certain load to the rail, lifting it up, and measuring the displacement, vertical displacement. We find out what is the SFT of the rail is at that time. These are some suggestions to use modern technologies. I'll just enumerate procurement on the basis of limited tenders from competing internationally experienced OEM. For products with life of 15-20 years, transfer of technology may not be insisted. Most IPR life expires during this time frame. Framework contracts for greater than 5 years may be considered, which justifies local manufacturing. Performance measured based specifications should be prepared based on international specifications such as UIC, EN, ARIMA, etc. Issuance of local licensing to multiple companies may be discussed to encourage if long-term and big volume purchases are foreseen. Single point system warranty must be insisted. This is the very important point for having modern technologies in place. Industry participation in forming of expert bodies should be considered, and policy on sustainable technology should be formed. Thank you.
All right, thank you so much, respected author. Let us move ahead with the second title of the paper, that is of Ether NDA Limited, UK, Eddy Current Railhead Inspection for Rolling Contact Fatigue. And for this, I would like to welcome our author, Mr. John Hanson, Director, Pandrol Ether NDE Limited, UK.
Hi, can you hear me? Okay, that sounds good to me from here. Hi, I'm John Hanson. We're bringing to you some technology we've been working on for nearly 13 years since the Hatfield crash in 2020, which happened very close to our head office in the UK. We are working with Modsonic, the well-respected UT trolley manufacturer, on that aspect, and here we go. This is rather large, so it's very blurry to me, so but probably okay for you at the back. This is the problem. This is gauge corner cracking. This is gauge corner cracking. This is what went wrong at Hatfield. They're very close together defects. They're probably 20 mil long. They're about, in this case, probably about 4 mil apart. And that's actually what happens if you break the rail open. And this is the fatigue crack. It's a very strange shape because the stress patterns are very strange, if you like. Next slide. Right. We do have a lot of things to do. So we worked with a company who are actually French, but they make NDT equipment in the UK, at least used to, called Geismar. That relationship now is ceased because Geismar no longer wish to support NDT equipment in the rail industry. So we have the trolley at the moment. The advantages of using eddy currents are many, really, but it's rugged, the system's collapsible, it's all self-contained. There are lots of other advantages. There's no water, weighs 9.5 kilos, it's affordable, it's repeatable, and it's fast. But we will have to go fast to keep going. So, and by fast, I mean something like 46 kilometers per hour up there. There's no need for surface gravitation, there's no couplant, there's excellent lift-off characteristics, it's really tolerant to changes in shape of rail. It's excellent for detecting surface breaking defects, and that's kind of pretty much all it does, in contrast to UT, which you're looking for the subsurface defects. And the probes are fairly easy to make for us. It's single-handed operation, it fits onto a single pelly case, so that's basically, hang on, oops. Oh, we'll just stay on that slide, I think. It sits in a single pelly case, could be readily transported to site. It collapses down, it's very compact. Right, okay. This is kind of what it looks like. This is it in use. That's very easy. The system's encoded. We can log many tens of kilometers of track on the small unit that's attached to it. And we'll keep going, because we've now got 7 minutes and 11 seconds. The system has a series of rolls. There are some fixed ones, and then there's like taking a thing from the rail industry, there's a bogey here, and the probe itself does not contact the surface. We normally set like a 1 millimeter gap on it to maintain it at a reasonable distance from the material surface. The probe kind of looks like that, or here's one in my hand, just to give you some idea of scale. It's curved over here to go round the gauge corner, and it split into, does one inspection of the whole head of the rail, and then a more critical inspection of the gauge corner. And we'll see that in a second as well. So it covers 30 millimeters around the radius of the gauge corner. And the probe is actually 2 channels, and there's 2 strips of data. Oops. Right, then we have, the instrument is kind of fairly compact, very easy to actually hand carry as well, and can also be used for standard eddy current applications like looking for cracks around fish plates, etc., which is kind of the most thing. And we can store over 1,000 kilometers of data on our instrument, which is more than anybody else wants to, really. There's a user interface. We won't go into that too much, but basically you can operate, you can put in waymarks and all that kind of stuff while you're going through it. I mean, we developed this with help from people in the railway industry, so this is not something we made up ourselves. And we have 2-channel display. You can see there's a red and a blue trace here. Oops. And we also there's a PC application that allows you to zoom in, move along the length of the track and see where you've got problems and defects. Okay, a bit of a better view of the PC app. So you can view the data on the instrument, and the app also presents to the operator in real time while the test is going on. Okay, so we put this in because we thought we should try and answer a summary of all the questions we got asked this week, or yesterday, basically, and this morning about it. We are specifically looking in the head area for defects emanating from the running surface, so from the outside. But this is interesting in 2 ways, because we're getting into the gauge corner, which UT doesn't readily inspect, and we can also detect transverse defects, which UT, due to the orientation of the probes, is also not very good at dictating. We can also detect transverse defects, but I give those two as examples because they are kind of the difficult ones to find, not the, and then obviously UT is doing all the defects in this blue area and down the web, in the head area, Tasho vowel and stuff like that. And one interesting application is, yes, this could be used to find defects in an in-service rail, but of course the other thing is that if you grind the track, mainly to remove cracks and other defects, actually you disguise the fact that there are defects there as well because of the surface texture. And we can run this behind the grinding train and find defects. So I think it can be used in conjunction with UT to make the UT better, but also it could, in its own right, it has some reason for existence. Okie dokie. This is actually, so if you come to stand 18, you can see this real time. We've made some, Modsonic made us some notches in some Indian rail for us, and they are some longitudinal notches, which follow this sort of basic formula: 0.5 millimeter deep, 1.5 millimeter deep, 3 millimeters deep, and then different lengths to simulate defects. And then, but as you appreciate, these are actually quite shallow defects in railhead. And then gauge corner ones following the same situation, but obviously it's slightly more tricky because you're now going around a curve. But up here are the responses from these defects. This one's kind of hidden down here a bit, so it's not a brilliant output. That's the 0.5 millimeter deep by 7 millimeter long. And then this we've probed around and seems to be something to do with this. This rail actually has magnetite oxide stroke mill scale on it still. It's never been used. It's a brand new rail, if you like. I mean, it's got quite a lot of corrosion on it, but it's not thing. But if we now go onto the gauge corner, these 1, 2, and 3 responses on the right-hand side, you can see we're getting on the left the longitudinal defects are in blue, and if we go over to the right-hand side, we'll see we're now getting red and blue spikes in the same place, and that's because these are confirming that these defects are in fact gauge corner cracks, and the severity changes in line with the relative size of the defects. Okay, 1 minute, right. Brilliant, you see. So Modsonic are distributing this for us exclusively, and we are working with Modsonic on making it for the domestic market in India, and that's what the plan. And Modsonic is part of the Elecon Group, which is a very respected business here in India, and we're from the UK, as we said. I'm not sure whether you're allowed to take questions now or whether we have only got 37 seconds.
Time is almost up.
Yeah, that's probably it, really. Bit of advertising, so please get in touch with our friends at Modsonic. But we have quite a lot of inquiries to follow up from this exhibition this week because it's been really good for us. There's been a lot of interest. Yep.
Thank you. Thank you.
Thank you.
Great, thank you so much, respected author. Let us move ahead with the next paper, and the title of the paper is Planius Technologies Underwater Inspection Solutions Using ROVs. And I would like to call upon the author, Mr. Vishal Devadas, GM, Business Development, Planius Technologies.
Hello. Thank you so much. I'm Tanuj, founder of Planis. Um, Pleasure to be here. Planis is a startup that came out 8 years back, where we started working on indigenous underwater technology for inspection purposes. And over a period of time, working with railway, we've been working with railways since the last 5 to 6 years, understanding field conditions and improving on the technology. So today I'll cover, what all we do until where we've gone. So I'm sure everybody's well aware of these numbers. And more recently, there's been a lot of mandates to use modern technologies like drones for underwater inspection, monitoring water levels, and 3D scanning or bathymetry of riverbed. So that's where we are trying to focus on. Our solution has 3 broad verticals. One is the underwater robotic platform that is used for data collection. Second one is the sensors and technologies that go on the platform. This could be visual inspection, NDT survey, sonar surveys, and then the interpretation and representation of that data to make decision making easy for the relevant bridge engineers. So already this has been deployed in more than 100 railway bridges across India. 10 railway bridges we've also done 3D scanning. More recently, we've also piloted the real-time scar monitoring, and more than 300 reports have been generated out of this technology. Of course, this technology has several other applications for India that we've deployed this at. So this technology has been deployed in many parts of India. There are some highway bridges as well that this has been deployed at, state highway bridges. I'll just quickly go to the video in interest of time. Yeah. So today, most of inspections have been done with divers in the past, and with over the few years, underwater robotic technology has been deployed. So these are unmanned robots that go in the water instead of the diver and collect different kinds of information. So we have developed our own systems here. There are many other systems that are available, and these are lightweight, portable, easily deployable. And since we've built it by ourselves, we have the ability to customize by integration by many other sensors. So we can go up to 350 feet, 120 meters. There's live streaming to the engineer. They can see the data live. And we do visual inspection to begin with in murky, turbid waters, identifying defects, categorize them, whether it's a cavity, crack, honeycombing, rebars exposed, spalling, and so on. And so these are some visuals from bridges we've deployed this technology at. We can also extract dimensions from it of what is the size of these defects. And we also do inspection in murky and turbid waters as well, which in many rivers are very murky. Moving forward, we've also integrated the bathymetry survey, sonar survey, which we can do in 2D and 3D, where we recreate the complete environment. And more recently, we've also introduced some underwater concrete testing sensors that tell us more beyond visual inspection. I'll come to the dashboard piece after that. Just some visuals of site deployment is coming up now. Yeah, this is a slightly older video, so this number has been quite updated. Yeah, so we've done some we've got the opportunity of doing some iconic bridges. We did the Pampan Bridge, Krishna Setu in Bihar. Few turbid water rivers in Hooghly we've done for Kharagpur. And then, yeah, we've also done some other smaller bridges for highway. When we need to do it for riverbed profiling, this converts to a surface craft, and then we collect GPS data and underwater data and tag it. So it's a very young team working behind this over the last few years. This lab, R&D lab, is from Chennai, and we have young engineers working on this technology solution. More recently, we also got an opportunity to pilot the real-time scar monitoring, which has been required over the last few years, where we deploy sensors, fixed sensors that are mounted on the piers in submerged conditions, and data collection continuously happens. Now, where this becomes important is many bridges or most bridges may be unmanned, and as rivers are flowing over a period of time, scouring information could be relevant. So this gives real-time scouring data, which and then we can put alerts based on if it crosses a certain threshold. Alerts need to be sounded. So it's a sonar-based sensor that's mounted on a truss system, which is installed on the pier. So this continuously keeps taking the data. We collect data 1 every minute, so over a 24-hour period we have enough readings, and we can then figure out plots over months, seasons, and in case there is a flooding event during that period, we have enough data. Challenges in building this is to make it proof enough so it doesn't flow away with the river, to make it so that nobody takes it away. So the cabling goes up, we have a solar panel powering the control box, and all the data keeps getting pushed to a cloud, which and then that is the final deliverable that goes to the railway engineers. Yeah. So once the data gets collected, one of the biggest challenges earlier when we spoke to customers was we do a bridge inspection. It takes us say 2 weeks. 2 weeks means 6 hours a day over 14 days, 100 hours of data is collected. And it's a very big challenge in reviewing these reports, reviewing videos. And often this data can only be single time used, because how does one compare 100 hours of videos for every year? So we also happen to put together a digital platform on which data gets put, and we get hotspots that on which part of which pier at what depth, what are the defects, and then you have a clear nomenclature of these defects. And when we click on these defects, you get a video and image of it. So apart from a PDF, this is also that is delivered. This is a preview of what it could look like at scale when multiple bridges are inspected. So you have one central repository for data management and moving it. A few case studies. So we did a bridge where you can see some of the defects that were found, and these were around cavities, honeycombing, turbid waters. And in another bridge in the same zone, we also did the riverbed profiling. So finally, there were some sections where light blue, where you can see where potential scouring could have happened, and relevantly that was information for the engineers. Another one, so this is a very interesting case. This is not in railways. It was for another state highway bridge where tilting was observed in one of the piles, and we were called in. So first we did a 3D sonar survey. We found a potential crack, and then we supplemented it with a visual inspection to identify that the crack did exist. And because these well foundations were many, it would take time to do visual inspection. So 3D sonar was the fastest, and this one was the result. So this is the center pier. So finally, what was found is scouring was 100%. What I mean by that is, at construction, the water level was 10 meters, the bed was 10 meters, and there was bedrock. Now we have 20 meters of water. So 10 meters of bed has been eroded over 50 years. And this is resting on the bedrock as of now. So there we can see there is a horizontal observation, potentially a defect, which then we did visual inspection with. The last case study, again, this is for a highway bridge where we found cavities so big that a complete machine went inside it and came out. And we're talking about 1 meter length of machine. So these were, and it's a river that is perennial it is perennially having water. And so you can see the heat map. So this bridge was immediately shut down and repairs were done immediately. So that brings me to the end with time up. There is just one last 30 seconds use case. We recently also deployed this technology for bridges that were recently made. So often we always get a question, bridge to naya hai, inspection kyo karna hai? So surprisingly in this, there were many construction defects. So when the foundations were laid, there were several defects found. And if inspection was done 1 year later, authorities would have been scared that in 1 year has the deterioration happened so much. So this was done in time that the contractor had not signed off. So the contractor was again called in to repair those defects and hand over the asset in prime condition. So due diligence survey or handover survey also is relevant because in underwater one cannot see after construction unless you get data. So that was another interesting example of how this can help keep assets safe. Yeah, thank you so much for your time. And
All right, thank you so much, respected author. Let us move ahead with the next paper, and the title of the paper is JSW Cement Limited, Use of Slag-Based Products for Strong, Durable, Sustainable, and Green Concrete. And for this, I would like to invite our author, Mr. Prajwar Thakur, GM Direct Sales, JSW Cement Limited.
Good afternoon, everyone. Namaste. I am Sandeep Singh from JSW Cement Limited. Today, we are going to present on our topic, use of slag-based products for strong and durable, sustainable, and green concrete. About the JSW group, we have total 8 verticals, starting with JSW Steel, which is our parent company. Then we are present in energy, paints, infrastructure, paint, cement, foundation, sports, and venture. JSW Steel being our parent company. So talking about the JSW Cement, we have a current capacity of 17 million ton. We have a plant of 25 million ton by the end of 2023. So these are the product portfolios. We are mainly present into the slag-based product called PSC, then OPC, then our green and sustainable product which is called as GGBS. So these are the plant locations. We are mainly present across west, east and southern part of India. We have our clinker unit which is at UAE, Fujairah, which has a current capacity of 1 million ton. In case of Maharashtra, we are producing our product at Dolvi, which is at Raigad. So talking about GGBS, GGBS is basically a ground granulated blast furnace slag, which is a byproduct of the steel industry. So on the left hand side, you will see the typical diagram of the blast furnace, where we add the iron ore, the coke and the high grade limestone. So once we melt it at a temperature of 1500 degrees Celsius, the entire steel parts, which is heavier in specific gravity, settles down on the bottom. Through tap hole, we take the molten slag out, and on the further part, there is a slag. Through sieves, we take it out from the blast furnace slag. Then we quench it with the cold jet of waters. From 1500 degrees Celsius temperature, we bring it down to the 100 degrees Celsius temperature. This is how the calcination process starts. GGBS basically is a partial replacement of OPC material and other cement supplementary material. As per Indian standard, we can replace ongoing OPC cement anywhere between 25 to 65% as per the various applications of the concrete. So this is how GGBS works. When OPC reacts with the water, CSH gel gets generated. In addition to the CSH gel, there is a calcium hydroxide also, which basically has a nature of expansion. If you see, there must be lot of concrete cracks in the mass concrete structures. With COH2, our GGBS reacts and further can make the CSH gel, which helps a long-term strength duration. These are the chemical composition of GGBS. It has a silicon dioxide around 37%, calcium around 40%. It comes from the cement family only. If you see the graph, the chart, it has a lime content around 40%, whereas the cement has a lime content of 62%. That's why we call it product is related to the cement family only. If you see, the fly ash has only 2% of the lime content, which is basically reacts with the water. These are some of the advantages of concrete made with GGBS. First, the green product, concrete made with eco-friendly material. Secondly, it has a high resistance to the sulfates and chlorides. Reduction in heat of hydration, like railways, there are a lot of mass concrete structure where we need to lower down the heat of hydration. There, GGBS could be helpful. Cracks can be avoided. Long-term strength can be improved of the structure. So this is a very interesting study conducted by IIT Mumbai. So we have a short time, so I'll quickly update on that. So if you see, if you are using 100% OPC, the long-term strength, the IIT Bombay has conducted a testing 3 days, 7 days, 28, 56 and 365 days. 100% OPC at the age of 365 days is providing a strength of 67 MPa. Basically, they did the trials on 400 kg cement and the various replacements 60-40, 50-50, 60-40 and 30-70 was done. If you see the 100% of OPC at the age of 365 days, its strength is lesser than what the 70% GGBS and 30% OPC has. Any structure, whatever we are making is for the long term only. So this is a flexural strength. These are the major infrastructure project where we are approved: Maha Metro, Municipal Corporation, Nagpur Metro Rail, MSRDC, NHI projects. Then we are also present across various, these are the list of specification and codal provisions. As per GGBS is manufactured as per IS 16714. We have various approvals from the municipal corporations of Mumbai, Pune and Nagpur regions, the metro. Recently we have started supplies to DFCC projects as well. And we have recently approved from the MSRDC and additionally Airport Authority of India in the PQC structure, paving concrete, GGBS is mandatory to use there. We have different approvals from MORTH and IRC as well. So coming down to the sustainability part, what the entire world is talking about, even our PM Modi is also talking about lowering down the carbon emissions in India. So if you see cement is almost contributing around 7% in the entire CO2 matter. So JSW with our product GGBS and the slag based mixed products, we have a solution to lower down the carbon emission anywhere between 25 to 44% depending upon the structure, the type of concrete, the type of strength which you desire, because the GGBS replacements are anywhere between 25 to 70% without affecting any type of concrete strength, the durability and the sustainability. Our products are IGBC approved. We have approvals for our GGBS and the PSC cement from IGBC. Recently, we have received approvals from Greha as well. This is very interesting chart. If you see the global average, so it shows if 1 metric ton of cement is produced anywhere in globally, if you see across all the cement companies, the averagely 608 kg CO2 is generated. India is doing far better than global. We have 560 kg of CO2 produced after every 1 metric ton of cement. JSW has only 216 kg CO2 produced after every 1 metric ton of OPC. That's why we are called as the world's first eco-friendly cement company. We have only at 216 kg. So these are some of the examples where 100% OPC, 75% OPC, 25% fly ash, 50% OPC, 50% GGBS mixes are considered. If you see the red highlighted, CO2 footprints, embodied carbon emission is reduced almost by 29%. The concrete which is made with 100% OPC and made with GGBS, 42% in terms of OPC versus OPC GGBS mixes and around 18% in comparison with the fly ash mixes. So this is how JSW has contributed to the environment. In last 6 years, the GGBS which we have sold to the various infra projects, around 8 crore cubic meter concrete was produced. With that reduction of OPC, around 1.233 crore metric ton OPC was saved. Since OPC was not manufactured, the electrical energy got saved, thermal energy was saved, mainly around 91.2 lakh metric ton of CO2 emission was not made to the environment. As per the thumb rule, one tree in its entire lifespan consumes around 1 metric ton of CO2. If you see around 91 lakh metric ton, like almost we have we have contributed planting a tree of 91 lakhs. These are few case studies, underground metro rail, Colaba to Seeps. These are mixed design, almost 45% GGBS. We are also approved in Airport Authority of India, Kempegowda International Airport. There in PQC structure it was used. Cable State Bridge, Juari Bridge, which is at Goa, southern part of the Goa. You will see the beautiful structure. It is entirely made with GGBS. Cable State Bridge mixed design. AP Amaravati is a new capital, currently which is on hold now. This is very iconic project. Everyone must have listened about it. The MTHL, Mumbai Trans Harbour Link. Starting from the project till the completion, we have supplied a huge quantity of GGBS to this project, L&T. If you will see, the round replacement was close to 65% in the mixed designs. Pune Maha Metro, these are the major infrastructure authorities where we are supplying the GGBS, like SIDCO, Mumbai Municipal Corporation, MSRDC. These are some of the government contractors like Tata, L&T, NCC. Some commercial developers using GGBS. These are some of the contractors. These are the major commercial RMCs which are using our products, green products. Major residential and the building segments also, we are usually present across Pune, Mumbai, Hyderabad, Chennai. All the major developers, we are supplying material to them. Thank you, everyone.
Thank you so much, respected author. Let us move ahead with the fifth paper, and the title of the paper is CEIL, a third eye to ensure quality. And for this, I would like to call upon our respected author, Mr. Pawan Kumar, Assistant General Manager, CEIL.
Good afternoon, everyone. Greetings of the day from CEL. Thanks to the organizer for this chance. My name is Amitesh Mishra, and my colleague is Mr. Anirban Datta. We are going to introduce ourselves by these slides. This is CEL, that stands for Certification Engineers International Limited, which is a wholly owned subsidiary of Engineers India Limited and a Government of India undertaking. It's a PSU company and MSME also. This is incorporated, this formed in 30 years back in 1994. We are into the services. These are our accreditations and approvals. We are the only PSU inspection body having Type A certificate as per ISO 17020. We have ISO 9001 QMS, PNGRB approval for audits such as IMS, ERDMP, T4S audits, PESO approval, IBR approvals for India as well as outside India. We have specially mentioned, we wanted to specially mention, we have approvals from Railway Board as a TPI agency for fabrication of inspection of girders, and which must be circulated in all the zones of railways. And we are looking forward to work with all the zones. We have pan-India presence as well as we have offices outside India. These are our experience credentials. We are into offshore business, onshore business, oil and gas, refineries, all the Indian refineries we were part of it, petrochemicals, pipeline, infrastructures. We do audits as per PNGRB guidelines, statutory HSC audits. We are competent authority from nominated by IBR. These are our services offerings. We have categorized it into 4 parts, that is established, emerging, sunrise, and new areas where we have just entered. So I like to mention about vendor inspection, vendor assessment, quality assurance to railways, construction supervision, where we can be very useful to railways to ensure timely completion of projects with quality, ensuring with the relevant codes and standards, compliance. This is our technical capabilities and of our inspectors and auditors. We have competent inspectors in all field of engineering, in mechanical, electrical, instrumentation, telecom, civil. We have safety people also. and their competency starts from NDT level 2. We have CSWIP 3.1, 3.2, SSPC, that is painting course level 2, PAUT level 2 people. These are some major clients, including Indian Railways, KRCL, state governments, Petrofac, ONGC, etc. This is our entry gate to railways, USBRL project, where we were involved into Chenab Bridge as a quality and inspection agency, and Anji Bridge also, which is first Indian Railways cable stay bridge. Apart from these two bridges, we were also part of USBRL 16 major bridges. We have provided quality and inspection services. Apart from this, we also do inspections at vendor end for bearing, HSFG, fasteners, sleepers, paint material, steel material. Here are some pics of Anji Khad Bridge. This is offshore expertise, where we have spent 30 years till now to do the offshore things. Offshore, I wanted to explain something about offshore. Offshore is extraction of oil from sea. So this is deck, and this is jacket. So this jacket is inside the sea till 70 meters. Seabed is at 70 meters, and the piling is at 150 meters. So we involved into that heavy fabrication. The weight of the deck is approximately 3,000 metric ton. Jackets are of around 3,500 metric ton, and it includes heavy fabrication, NDT technology, weldings, and this is our credentials. We have completed that much of jobs with ONGC and offshore other parties. This is our credentials for refinery, petrochemicals, and pipelines. We have provided services to almost all refineries till now, and we have specialized engineers in all streams: electrical, mechanical, instrumentation, civil, health and safety, and they can perform inspection at vendor's end for the procurement as well as during the execution of the project. We are into infrastructure. We work with municipal corporation, various municipal corporation involved in building construction, road constructions, water treatment plants, etc. Our expertise in instrumentation, electrical and telecom in terms of we do inspection at vendor end from generation of power, means generator, transformer, motors, HTLT, cables, till switch gears. We also do DCS, PLC at vendor end as well as during execution, installation, commissioning of all these systems at site. This is something where we are expert, that is legacy of 25 years of CL, expediting services. This is very important for the completion of project, timely completion of project. Here we do provide support to the client since the issuance of PO to vendor or the contractor, and we ensure the monitoring of the project, reporting of the project, as well as if any hiccups, so raising the red flags to ensure the completion of project on the time. It includes drawings, approvals, and we have dedicated formats for the reports of it. This is where we can help CL's importance in these terms. We are independent, impartial, that is third eye to ensure quality. Expertise, expert engineers, specialized engineers, as I explained earlier, who ensure quality assurance, risk mitigation, efficiency, and meet the timelines with the compliance of codes and standards, whether it is international codes, RDSO codes, or IS codes. Here's something explained about the fabrication stages. We do inspection from the stage of raw material inspection, fabrication, of course NDT, our people deployed at the site at the vendors, fabricators yard, and we especially perform the trial assembly at the fabricator end to ensure there is no hiccups at the last moment during the trial assembly at the site. We are proposing to collaborate with Indian Railways with all our this specialized service. As I already told, this is, sorry. We do procurement inspection at vendors and for mechanical, electrical, instrumentation, telecommunication items. We do TPI services, third-party inspection services for project execution during fabrication as well as erection. We do vendor assessment to ensure the vendors who railways are selecting are competent enough. We do thorough assessment of them. We have our own system. We can follow our SOPs or as per the requirement of client SOPs. We do expediting to monitor, report, and highlight issues which can affect project progress and ensure timely delivery of projects. We do quality assurance. We have standard formats which can be useful for railways to develop the quality documents like ITP, QAP, FAT, and we can also review it post-development. Technical services, this is where we can help in during execution of project. Construction supervision services, since starting from the incoming material inspection, commissioning mechanical completion, till the handover to the client. We ensure all the stages are completed with compliance to the required standards. We do structural audit, HSC audits, electrical safety audit, energy efficiency audit. We do remaining life assessment of structures with the help of our parent company, Engineers India Limited. HSC system. In terms of HSC system, we can formulate procedures, reporting formats to railways. We have our in-house formats, and we can also help in during execution of HSC things. What I have explained, our expertise can be utilized in the sectors of Indian Railways. In these sectors especially, that is bridges, station development, route electrification, signaling and communication system. Over to my colleague Anirban Datta.
Our engineers are very much expertise in this welding process, generally used for the railway girder bridges, like SAW, GMAW, FCAW and SMAW, where it is very commonly used in the steel girder fabrication, which is also used in the Chenab Bridge, Anji Bridge and 16 major bridges under USBRL project. And we made some comparative analysis where the different welding processes against their parameters, which are more suitable to the jobs. And like SAW welding, which is limited to the flat position, but it has an advantage where the high speed and good weldability and can be achieved. But in case of the geometry of the component, due to portability of the FCAW, GMAW, where SAW cannot be used, where those welding processes can be used. And SMAW, where the non-critical item like handrails and other non-critical items can be welded by this process. So we want to highlight the key determinants of the welding quality during the welding and pre-welding. So our engineer always check these parameters religiously during the inspection of welding. So we always ensure the approved WPSS, relevant consumable, use of relevant consumables, welder qualification as per the relevant process and position, where the position having a vital role in this. Proper welding sequences, methodology, monitoring welding parameters like generally weld geometry, polarity, current, voltage, travel speed, and backing, flux and electrodes, preheat and interpass temperature, which is always being checked by our engineer to ensure the getting a sound quality. So where many of the industries we have observed that these stages are missed by them. So we always be ensuring these determinants. And the NDT techniques where our engineers are very much competent over these techniques like VT, ultrasonic, RT, DPT, MPT, and advanced NDT techniques like PAUT, TOFDs. We have qualified PAUT and TOFD interpreters. And NDT techniques which have been comparative analysis have been put here in the tabular form, where the phase array ultrasonic testing, which is adopted in the Chenab bridge, which having a radiograph advantage over the radiography testing, where the radiography testing laminar defect cannot be checked, where PAUT can check the laminar defects. So our engineers are well competent for interpretation of this. And magnetic particle test and DPT also carried out for the surface and subsurface up to 2 to 3 mm, where our engineers are well competent with this.
That's all for now. Thanks everyone. You may visit our stall number 4 if any queries, further queries. Thank you.
Thank you so much, respected authors.
Just a minute, a small clarification before you leave. All these exercises that you are telling that you will be carrying out, or you are carrying out, this is by in-house staff or you are subletting to others? How much is the strength? I mean, what is the percentage of work that you do with your in-house vis-a-vis outside people?
We have our in-house engineers who qualified all the NDT level 2s for interpretation. And yes, we are also recruiting the engineers for some of the cases, but mostly we are using our engineers, and our engineers are also PAUT qualified, level 2.
The people are your in-house?
Yeah, in-house. For inspection purposes,
we have
sir.
Team of experts.
Thank you, sir.
From the audience, any question from any of the speakers may kindly come up.
All right, let's move ahead with the Q&A round, and for that I would like to call upon our authors on the dais, Mr. Sashi Kant Mishra, Mr. John Hansen, Mr. Vishal Devadas, Mr. Prajwar Thakur, and Mr. Pawan Kumar. I request you all to kindly please come up on the stage, and we'll begin with the Q&A round.
Hello. There is this question for the first presentation. It says that, is there any reinforcement provided inside the boot in case of Pandrol booted BLT? From Mr. Deepak Sablok. So reinforcement is provided inside the precast concrete block, but apart from that, if it is in tunnel, where there is lesser temperature variation, there is no reinforcement provided necessary in the cast in situ concrete. but or at subgrade or at bridges where it's exposed to the environment and temperature variations could be large, there temperature reinforcement is required. But inside the boot, if I understand correctly, the precast concrete block does require reinforcement. It's a reinforced precast concrete block. Another question is from Mr. P.K. Samant Roy ji. It says, can we lift the rail after removing fastening to check rail stresses? Yeah, so you have to remove the fastening for a length of about 33 meter. And you have to lift the rail in the middle of that, in that section. You have to declip the rail for that length, and you have to lift the rail in the middle of that section with that given force, and then check what vertical deflection the rail has suffered. And based upon that, you have to calculate the SFT. Another question is from Mr. Veer Narayan. In embedded rail system, is CWR permitted? If so, has the expansion contraction of rail is handled as rail is not fixed? So yes, it has been done on continuously welded rail, because you anyway have to bring the rail you already have to prepare the rail with these encapsulation off-site, and once these rails are encapsulated with these rubber profiles, then you have to bring the rail on-site and then support it with GIF. And due to the expansion and contraction of the rail, it is lesser than when the rail is exposed to the environment. Here in this case, because it is encapsulated by rubber profiles on all three sides and only head is exposed, this temperature variation is less. So expansion and contraction is lesser as compared to a normal situation. But yes, it is permitted because it is encapsulated within resilient profiles, and they are also free to move a certain by a certain distance to accommodate that expansion and contraction between the rail and the rubber profiles. So I had these three questions. You may come up. Thank you.
Yeah, so the first question to me is for the underwater inspection. What is the mode of contract working by us? And do we give the instrument on hire or take complete work? So there are two things. When inspection is concerned, it's a job for a bridge or anything. So we come in with our equipment, collect the data, and give the final report. But when it comes to the scar monitoring is when we give the instrument, we install it on the bridge, and that is a property of railways after that. Hope that is answered. And yeah, there's another question on costing. So to get more costing and time for every project depends on the size of the project. It can vary anywhere between 2-3 lakhs a bridge to crores, depending on size, depth of water, and tests required, visual test, NDT test, sonar test, and so on. So yeah. Second question is, since the data is stored in digital format, can a defect propagation in a timeline be monitored? So for underwater inspection, the data is collected and delivered. It is static. It is not real time because the data collection is done once. But for the IoT sensor, yes, it is real timely monitored. Thank you.
Hi everyone, I have a question from Mr. Sharad Mehta. Is there any cost and price advantage to use GGBS over conventional Portland cement? So yes, Mr. Sharad, there are definitely a cost advantage. If you see the current ongoing price of cement is close to 8,000 rupees a metric ton, whereas GGBS is 50% of OPC. We are closely 4,200 rupees per metric ton, including the GST. In addition to the cost benefit, there are long-term benefit of using GGBS. Like if you talk about cement, there is some specific strength which will OPC attain. But in terms of GGBS, as I've shown in the IIT study, GGBS has a long-term strength advantage. I hope I have answered your question. Thank you.
All right, thank you so much, respected authors. Now let us move ahead with the presentations of the mementos to our chairman and co-chairman. And for this I request Shri B.K. Gupta, AMCE Railway Board, to kindly come up on the dais. All right, before we go for the presentation of the mementos, we're going to have the reviews.
Respected Chairman, sir, Chief Guest, other dignitaries and speakers. The number of queries speak about the interest in the new technology we are having. Yesterday, actually, we listened to many speakers, including our Honorable MR and Member Infrastructure. Indian Railway is definitely going through a big transformation. And the target, 3,000 metric ton target, high speed and high axle load. And actually these are very, ambitious, this thing. And it cannot be achieved without the active support of the industry. We have seen that during construction or maintenance, most of the things we are procuring through the industry. I will say I do not have the data, but it's all procurement, either material, machines, or whatsoever you say. Rest other things are supervision and some execution. So we are spending huge money in procurement. So innovation there in our products and their cost is very, very important. And thereby, the support from industry is very, very important. And we cannot live in isolation. And we have to be always in touch with the industry, and we have to be always updated with the latest research and development. Actually, today, 5 papers have been presented very beautifully. Excellent papers were there. And it invited a number of queries, which that has been answered by speakers. The first was Penroll, the modern solutions for Indian Railways. In fact, what he talked about was embedded track. Actually, about a year back, we were looking for, because embedded track, I saw a number of benefits it has. In India, especially in hilly area like Himalayas, I can say, Government of India is thinking of, already they have sanctioned, they are going ahead with the strategic lines. And many tunnels they want to use for the road transport also. In case of emergency, in case of war or any this thing, I think this is the best suited solution for the tunnels in the strategic area like Northeast and Northern Railway, I can say. It has a lot of advantages. I don't know the cost-wise, but definitely if we adopt at a larger scale, then cost will definitely come down. Then booted block section, this block system, they are already using in number of tunnels, they have covered. But the thing is that we have always been very worried. The seniors, and in fact, we also, only 1 or 2 years back, we were very concerned about the derailments in the tunnel on the ballasted track if we adopt. And recently on 10th August 2023, the longest tunnel in the world has been closed down for several, I think it will open only next year. because there was one train that capsized there, and they are in the process of restoration. So that aspect has to be also addressed by the service provider. Second was eddy current railhead inspection for rolling contact fatigue. That is very good, because so far we have been limited only to the web and head scanning by our conventional USFD method. Now they are augmenting it with this eddy current method. That is augmentation over that USFD, that surface crack and the gauge corner cracks also, very minor cracks also they will be able to detect. So I think it is going to aid to the safety of the running traffic. Then third paper was Planage technology by underwater inspection solution by using ROVs. It's very when we, doctors, they have nowadays introduced, I mean, of course, technology is going very fast. So they are using some camera inside your body, and you can see yourself what is happening live. So this is like that. I could see some of the photographs. So you can see how your structure you have built, I mean, we have built over, and how it is functioning. So we can see directly. And it will definitely warn us in time to deteriorate further and take remedial measures. Secondly, we can use, I think in the last they covered also, in new construction also, whether the structure we have built, whether it is meeting our good for construction GFC drawing, whether it is same thing, the product is same as we had envisaged. So that is also very good. And then fourth paper was by JSW Cement. Of course, strength-wise, high performance concrete. By using this one, we can get high performance concrete. Of course, we are going through the open tendering, so we should definitely, the company should go for the, look for the cost aspect also, how they will bring the cost, so that it should be comparative also with the other alternatives. But the very good thing is that we are going for, we are catering for the climate change, like green technology we are using. So I am very happy to note that against average of 802 kg this CO2 per cubic meter of concrete, per metric ton of concrete, they are only producing 216 kg. So this is a national mission also to reduce the carbon footprint. So that way it is very good paper and very good product. And the last paper was by CEIL. Of course, they are very old, I mean, well-established organization under EIL. And we all know that over a period of time, actually the infrastructure is growing with leaps and bounds. And there is need for a lot of inspection, monitoring and all that. And RDSO, we are not able to cope up with the existing resources. So the Ministry of Railway has gone for the engagement of third party. And by this process, I think this CEIL is one of the leading third party, I mean, they are the leading organization they are doing. And in fact, I saw that they are expert in welding as well as in offshore this system in ONGC and all. They have a very good knowledge bank from past. And I saw their papers, and they have a lot of good checklist and formats and manpower. So it is very, and they have gone, they have done Anji and Chenab and many other important issues. It's very good for Indian Railways. They are augmenting our capacity of RDSO. And they have covered welding sequence and the NDT also. It's very, very good. So I have a certain suggestion. Just I will sum up before I hand over to our chairman, sir. Actually, here we all come from all over Indian railways, but only few people come. And such interaction with the industry should not only be here. In fact, we have IPWE local chapters in every zonal railways. It is better that time to time, maybe at 3 months, 6 months, we should have such interaction with the industry because technology is moving very fast. And sometimes our people and even we do not know that what is happening in the market. And we are suspicious about adopting the technology. So if this type of interaction takes place quite frequently at the IPWE local chapter, like at zonal railways, better to understand and get the more confidence. Secondly, we are doing a lot of replacement also. But we should select some section, something where we should do post-auditing also. What is the amount we have spent on the premature replacement of the assets? Because it's not only laying or implementing or this thing, but we should know whether the performance is also to the desired standard or how much we are lagging. So we should tighten that aspect also. And now AI is in a big way in all over the world. So we should develop our entire system, a smart system, every system. We should have a smart track, we should have a smart inspection, we should have a smart means everything should be, human intervention should be minimum. So I think they all, industry is definitely going for that, and we should also be supporting them. Thank you very much. Thank you. Sir, Chairman, sir, over to you.
Thank you very much. I must thank my... Thank you very much. I must thank my co-chairman. He has already summed up very comprehensively. There are just 1 or 2 points which I want to make. In the first paper regarding modern track solutions for Indian Railways, very correctly it has been pointed out that this is a very useful thing, the embedded track, that embedded rail track. This is very useful for northeastern railway, northeastern areas and hilly areas in general, as my co-chairman has pointed out. In addition, this could also be useful for longer bridges. I am curious to find out whether such solution can work for long bridges also, because these are the 2 constraints. If we are having already a railway track and a long bridge near the border, a long road is being constructed, whether it will be possible to have such solution on a long bridge or not, that is something which can be thought of. Other is, of course, they have spoken about USP, but prolific use of USP has still not been done in India, which will be required in coming years. The advantages of USP are well known. Then with the change of organization which Indian Railways are presently undergoing, there is a necessity for a lot of administrative procedures to undergo changes. Now, these changes will call for new techniques to be employed. For example, prolific use of PMC will definitely be there, more and more PMCs, and this third-party checking, what CIL has told, have introduced, and they are trying to get contracts from Indian Railways. I think they are on the right lines, and more contracts of this type are in the offing. About the slag cement, of course, we all know the advantages. I am reminded of the times of early 70s or mid 70s when the use of slag cement in railways was initially banned. And dumping of slag was a big nuisance near the steel plants, and it used to occupy a lot of space. So it is were definitely much better from those era. We are where we are making use of slag and reducing the carbon footprint. And all other papers have been interesting. I must thank all our audience for very patient hearing. Thank you very much.
Thank you so much, sir. So let us begin the presentation of the mementos to our respected chairman and respected co-chairman. And for this, I would like to call upon Shri B.K. Gupta, AMCE Railway Board, on the dais, please. I request Shri B.K. Gupta to kindly do the honors. All right, everyone, let's give a big round of applause. Now we're going to have the presentation of the mementos to our authors by Shri B.K. Gupta. And for this, I would request all the authors to kindly please come up on the dais. Midst of us, we have Mr. Shashikant Mishra, Mr. John Hanson, Mr. Tanuj Junjunwala, Mr. Prajwar Thakur, Mr. Amitesh Mishra, and Mr. Anirban Datta. So first, I would like to welcome Mr. Shashikant Mishra. Midst of us, we also have Mr. John Hanson. Everyone, a huge round of applause. We have Mr. Tanuj Junjunwala. Can we have Mr. Prajwar Thakur? And Mr. Amitesh Mishra and Mr. Anirban Datta. All right, thank you so much to all the authors, and thank you so much to our respected chairman and respected co-chairman of the session. All right, ladies and gentlemen, before we head towards the valedictory session, we are going to have a break of 2 minutes, and then we begin with the valedictory session. Thank you. All right, the tea break is going to be after the valedictory session. So it's a break, a breather of 2 minutes, and then we begin with the valedictory session. Ladies and gentlemen, we're going to begin the valedictory session in the next 1 minute. So it's my humble request to everyone to kindly be seated. It's my humble request for everyone. I request you all to kindly be seated as we are going to begin the valedictory session in the next 1 minute. All right, ladies and gentlemen, so welcome you all at the valedictory session, and I would like to call upon our dignitaries on the dais. Mr. First, we have Shri B.K. Gupta, President IPWE India, Additional Member Civil Engineering Railway Board. I request Shri Rajiv Mishra, CEG, to kindly escort, sir. Mr. First, we also have Shri R.K. Yadav, Director General, IRISAN. We have Shri M.K. Gupta, Executive Director, IPWE India, ex-Additional Member Works, Railway Board. Midst of us, we have Shri V.P. Singh, General Secretary, IPWE India, Principal Chief Engineer, Northern Railway. Midst of us, we have Shri R.K. Arora, Shri Rajesh Arora, Principal Chief Engineer, Central Railway, and Shri R.K. Goyal, Vice President, IPWE India, and Principal Executive Director, Bridge Railway Board. I request all the dignitaries to kindly be seated. And as we begin, I request Shri V.P. Singh, General Secretary, IPWE India, and Principal Chief Engineer, Northern Railway, to kindly address us.
Good afternoon. Shri Brijesh Kumar Gupta ji, President IPWE and Additional Member Civil Engineering, distinguished guests on dais, fellow delegates, ladies and gentlemen. On behalf of Institution of Engineers, Institution of Permanent Engineers India, I would like to thank all the delegates and other participants for a very healthy and fruitful contribution in the seminar. We are sorry, due to overwhelming response, we could not incorporate all the papers in the seminar. Even for the papers included, the availability time was limited and full justice could not have been done to the authors for fully explaining their point of view. Our thanks to all the authors who have presented the papers and also those who had sent papers which could not be included in the seminar for want of time. We are grateful to the Director General IRISAN and his team of dedicated officers for all the efforts which have been made this seminar a grand success. We are thankful to the distinguished senior IRC officers for chairing of the technical session who in spite of the short time and other limitations could manage the technical sessions very well. Thanks are due to all of them. I also thank all the co-chairmen of the session, authors, members of the trade and industry. We are happy to see that apart from delegates from various zonal railways, a number of delegates came from other professional bodies, various PSUs from industries as well. Our thanks are also due to them. We are also grateful to our senior retired railway officials who have participated in the seminar. We value their contribution, sir, and thank you for the same. Our thanks to various firms and other railway units for installing the stalls and making the exhibition also a grand success. With these words, I declare the seminar concluded. Now I will request DG Resen to summarize the proceedings of the seminar. Over to you, sir.
Honorable President IPWE and AMC Railway Board, Sri P.K. Gupta ji, ED IPWE, Sri M.K. Gupta ji, senior officers and friends. The topic of the current international seminar are very much relevant to the present context, where focus is on infrastructure. This seminar had evoked overwhelming response as we have received 65 number of papers for this seminar. Total 50 papers were shortlisted for publication in the seminar proceedings. The quality of all the papers are very good. However, due to paucity of time, only 20 numbers of papers could be presented. In addition, 5 papers were presented by the trade. It has been observed that during the presentations, lot of interest has been shown by the audience. It is evident from the questions being asked from the speakers. Certainly, this must have enhanced the knowledge of the audience on this subject. At the end of each session, chairman and co-chairman have summed up the content of each paper in details. I would like to mention only few items from these topics, which may be part of the recommendation which we will send to the board. First items regarding rolling block. The specialized software has to be prepared for block planning, similar to control office applications. And I am told that DFC has already made some program, and on that basis, certainly some work has to be done in this direction. And as mentioned by MI sir, that this rolling block program that has to be made in the regular practice, so that at present it is doing very well since staging is being done by Honorable MR and MI. So this should come in the practice. Then regarding fast track constructions, these prefabricated bridge elements and ultra high performance concrete elements that has to be used for faster project completions. For piling works, in sandy strata, vibro hammer is recommended to use to drive liners for accelerated piling work. The system of pile draft is useful to avoid very deep piles subjected to very heavy load and adverse ground conditions. In case of cantilever erection method, designing of erection scheme and its proof checking considering 3D analysis should be made essential. Erection of long cantilever span from both ends is recommended for faster erection and reducing cantilever bending moments. Software regarding fabrication works, the software like Technical should be used to produce 3D drawing, and fabrication drawings should be extracted and used for cutting and drilling by CNC machines. Proof testing of welded part should be made with approved WPSS, that is welding process specification sheets, that should be done before producing actual components. Phased array ultrasonic testing in lieu of radiographic testing for butt welds joints of bridge components. For tunneling in strata with shallow overburden, it is recommended to improve the strength of overburden mass by ground improvement techniques such as grouting, micropile, etc. before using NATM. For increasing sectional speed, curve should be realigned for 160 kmph, if not 200 kmph in one go. It should be done in phases. To avoid cattle crossings, W-beam anti-crash barriers type fencing that has been used by Western Railway, that should be used for all Indian railways because its results are very good and cattle runover has reduced. Low stiffness of elastomeric bearings makes them unsuitable for continuation of LWR on long span bridges with tall piers. So if you want to continue the LWRs on these bridges, elastomeric bearings with shock transmission unit can be a possible solution. Steel friction sliding bearings is also a solution for this. Drone inspection combined with LiDAR technology and 3D photogrammetry can be used and aid for technical inspection of important bridges and inaccessible elements. Thanks. One more item regarding EPC contracts. A lot of discussion has been done on this. So, for successful EPC contracts, time delay and variation that should be usually provided in the tender documents, and Railway Board is doing on this. A committee has been formed and EPC documents that are being under revision. Sir. Yes, sir.
Just give me the mic. Yes. You know, just go back and where you're talking about curves for 160 kmph.
Sir.
I have a feeling that we should go in for those curves where major bridges are involved. Those curves should be realigned not for 160 but 200.
Yes, certainly. Certainly.
That we should incorporate, and
yes,
because otherwise, in the next step, which will be after a few years, we'll be hamstrung, and again a new bridge will have to be.
Sir, that will come in the detailed recommendations. Certainly.
That is, and another thing about the underwater thing. Underwater, you know, board long back, Railway Board had made a committee which ultimately could not give any recommendation at all. There were IIT professors also, but unfortunately there was no consensus among even the IIT professors, and no useful result could come out. That was regarding scour depth. Now, if you see the formulae of scour depth, they give you huge variation between the results of one formula and another. Now, it is the need of the hour that this Lacey's formula, which is definitely not correct, and a lot of money is being wasted away. Only 12 bridges in the country were done, and whole country is today working on that. So scour depth, which we are using, is certainly very much on the high side, but if we can get the correct value of this scour depth for a large number of bridges, we'll be emboldened to revise this formula.
Sir, certainly will take note of this.
I mean, this technology which they are talking about could be used to collect data for the scour depth.
Sir.
Thank you. Thank you very much. I'm sorry to intervene.
There is suggestion that the mechanism for documentation of projects that should be constituted so that details of projects executed are available at one place. Somebody has suggested IRSEN or RDSO. One more recommendation that will include that help of retired railway official that will be taken for any suggestion for improvement in the working for a technical solution for many problems. Thank you, sir.
All right, thank you so much, sir. Midst of us, we have Shri V.K. Gupta, President, IPWE India, and additional member, Civil Engineering Railway Board. I request him to kindly address us.
Respected senior officers and my dear friends, a very, very warm welcome to all of you and a very, very good evening. जैसा कि आप जानते हैं कि आज इस सेमिनार में जो 2 दिन का सेमिनार आज हम लोग कंक्लूड कर रहे हैं, इसमें हमारे जो सीनियर ऑफिसर्स हैं जिनको कि कुछ रिटायर्ड ऑफिसर्स के नाम से लोगों ने एड्रेस किया है, मैं ये कहना चाहता हूँ कि उनका रिटायर्ड नहीं है, बेसिकली दे हैव बीन रिटायर्ड. सो अल्टीमेटली उनका हम लोग पार्टिसिपेशन बहुत ज़्यादा चाहते हैं और ये ऐसी फोरम है जिनमें कि आप सभी लोग जो रिटायर्ड हो चुके हैं, बाकी लोग आने वाले हैं, तो आपका एक्सपीरियंस का वास्ट एक्सपीरियंस का हम लोग यूज करेंगे. तो मतलब IPWE तो पक्का ही है, आपको यूज करने वाला है. बाकी जगह और देखते हैं हम लोग कैसे तंत्र में कैसे उसका उपयोग लिया जा सकता है. जैसा कि आप लोगों ने देखा, मतलब जो मैं यदि लास्ट सेमिनार जो कोलकाता से हुआ था और जो अभी सेमिनार पुणे में ऑर्गेनाइज किया है, तो धीरे धीरे बेसिकली कंटिन्यूअल इम्प्रूवमेंट है और ये इम्प्रूवमेंट आता रहे, ऐसी हमारी सबकी अपेक्षा है और हम लोग ये सब चाहेंगे कि वो इम्प्रूवमेंट बना रहे. एक बार और मतलब सेंट्रल रेलवे को मैं बहुत कॉम्प्लीमेंट्स देना चाहता हूँ, उनको थैंक्स करना चाहता हूँ कि उन्होंने सारा मतलब जो कुछ भी सेमिनार का अपने वजूद लिया. और सबसे इम्पोर्टेंट बात ये थी जब इनको शॉर्ट नोटिस पे कहा गया कि आपने करना है, तो पीसी सेंट्रल रेलवे उनकी टीम ने इसको चैलेंज को एक्सेप्ट किया और बहुत ही शॉर्ट नोटिस पे इतनी अच्छी वेन्यू का सिलेक्शन किया और जहाँ पे सब लोगों को हाउस किया गया और सेमिनार को ऑर्गेनाइज किया गया है. दूसरी चीज़ इस तरह से निकल के आई है, लास्ट टाइम सेमिनार से हम लोगों ने ये डिसाइड किया था कि हर मीटिंग का, इतनी लंबी मीटिंग 2 दिन की मीटिंग करते हैं, सेमिनार करते हैं, इसमें विद इन दी सेमिनार अच्छे डिस्कशन होते हैं, पेपर प्रेजेंट्स होते हैं और आउटस्कर्ट पे साइड लाइन्स पे भी बहुत सारी बातें होती हैं. तो इन पे कुछ एक्शनेबल पॉइंट्स बनाएं और इन पे एटलीस्ट के बोर्ड के लेवल पे इरिसेंट बोर्ड और RDSO मिलके कुछ काम करें. तो लास्ट टाइम से हमने स्टार्ट किया था. लास्ट टाइम कुछ सजेशंस थे, वो सजेशंस हम लोगों ने बोर्ड के लेवल पे RDSO और इरिसन के साथ में मिलके काम किया है. कुछ काम चल रहा है, उस पर भी काम करेंगे. इस बार भी जो कुछ सजेशंस आए हैं, जैसे भी पेपर्स के थ्रू आए हैं, अदरवाइज या साइड लाइन्स पे आए हैं या इनफॉर्मल मीटिंग के थ्रू आए हैं, उन सजेशंस पे भी हम लोग एक्शनेबल पॉइंट बनाएंगे और बाकायदा काम करेंगे सो दैट इस जो IPWE की फोरम हमारी है, इसका इफेक्टिव और अच्छा यूटिलाइजेशन किया सके. IPWE अदरवाइज आल्सो IPWE को इंटरनली और इंस्ट्रक्शन दे दिए गए हैं. IPWE की वेबसाइट पे भी हम लोग बेसिकली जो हमारे सीनियर ऑफिसर्स हैं उनके लिए भी अलग से जगह बनाई जा रही है उसमें, सो दैट दे कैन गिव देयर सजेशंस जो नेक्स्ट IPWE सेमिनार होगा उसके लिए. अदरवाइज आल्सो IPWE की फंक्शनिंग, वर्किंग और उसका इफेक्टिव यूटिलाइजेशन कैसे किया जाए, इसके बारे में हम चाहेंगे कि आप लोग सजेशंस दें. ये वाली वेबसाइट पे इसका प्रोविज़न करने के आदेश दे दिए गए हैं, तो इसको हम लोग करा जाए. और इस सेमिनार से जो भी हम लोगों ने और सीखा है, क्योंकि इस सेमिनार में कुछ तो कितने बड़ा ओकेजन हो, कुछ कमियां रह जाती हैं इन टर्म्स ऑफ से अरेंजमेंट्स, प्रिपरेशंस ऑफ वेन्यू और अदरवाइज आल्सो पेपर्स एंड ऑल दैट. तो वो अगली बार आप सब लोगों के सजेशंस, चाहे वो वर्किंग ऑफिसर्स हों या फिर सीनियर ऑफिसर्स हों वो सजेशंस दें, डायरेक्टली वेबसाइट पे देने सकते हैं और अदरवाइज आल्सो ईडी IPWE को भी देने सकते हैं। दो चीज़ें इस सेमिनार से बहुत ही अर्जेंट जो हमारे वर्किंग ऑफिसर्स हैं उनके लिए निकल के आई हैं, जो कि बेसिकली एपेक्स बॉडी, एपेक्स मैनेजमेंट, एपेक्स लेवल पे ये चीज़ है अवेलेबल कि इनको करना है। एक तो सब लोग जानते ही हैं कि बेसिकली रोलिंग ब्लॉक का है, तो रोलिंग ब्लॉक के बारे में मिसकंसेप्शन किसी भी डिवीज़न को, किसी भी ऑफिसर्स को डाउन दी लाइन नहीं होना चाहिए, क्योंकि ब्लॉक पहले भी होता था। अभी सिर्फ इतना कहा गया है कि इसको ऊपर से करा के ये जरूर ये कराया जा रहा है कि हर सेक्शन में जितने टाइम का ब्लॉक बन सकता है वो ब्लॉक दिया जा रहा है और लोगों को पहले से पता है कि ये वाला ब्लॉक बेसिकली होने वाला है। देन हमारे सारे जो भी फ्रेंड्स SNT, इलेक्ट्रिकल, इंजीनियरिंग, डाउन ब्लॉक कुछ भी लोग अवेलेबल हैं, वो लोग बेसिकली काम करने की पोजीशन में हैं। तो इस रोलिंग ब्लॉक के लिए आपको इफ़ेक्टिवली सक्सेस कराना है, इफेक्टिवली इम्प्लीमेंट करने की ये कोशिश करना है। और जैसे पहले प्रेजेंटेशन में, पहले पेपर में दैट इज जो साउथ सेंट्रल रेलवे FIT ने प्रेजेंट किया था, उसमें एक बहुत अच्छी बात कही थी कि भाई आउटकम दिखाना पड़ेगा। यदि हम कुछ चीज़ किसी से कोई रिसोर्स यूज करते हैं, कोई हम डिमांड करते हैं, कुछ हम काम करना चाहते हैं, तो हर एक लोग ये चाहेंगे जो कि मैनेजर्स हैं कि कुछ ना कुछ आउटकम मिलना चाहिए। तो ये आउटकम दिखाने की पोजीशन में हम लोग रहेंगे कि देखिए ये हमारा काम हुआ है, इससे बेसिकली ये आउटकम मिला है, और अदर क्यों इसी में क्यों जो रोलिंग ब्लॉक के लिए बाकायदा जो हम लोग काम करते हैं उसमें भी हम आउटकम बेस्ड काम करें तो बहुत अच्छा रहेगा। और एक जो सेकंड एस्पेक्ट है, जो 130 kmph की स्पीड पे हम लोग काम करने जा रहे हैं, तो 130 kmph आपको पता होगा कि GQ GD ये सारा हो गया है एक्सेप्ट दो सेक्शन छोड़ के, और वो 2 सेक्शन भी ये नेक्स्ट मंथ एंड तक हो जाएंगे। तो कंप्लीट GQ GD हो गया है। 130 kmph के जो रिमेनिंग 100 बी रूट्स हैं उन सब में भी बेसिकली 130 kmph का हो रहा है। तो इसमें चूंकि सेफ्टी फेंसिंग अभी मैंडेटरी नहीं है, उसको बेसिकली डिजायरेबल कहा गया है, तो सारे लोगों से डिविजन्स एवरीबडी उसको बेसिकली उस तरह से काम करें कि पॉलिसी मैंडेटरी नहीं है, बट आप लोगों को उसमें काम करना है कि सेफ्टी फेंसिंग लगाना है। बिकॉज कैटल जैसे ही स्पीड बढ़ती है और कोई कैटल का मैनेज होता है या ड्रिलमेंट होते हैं या कैटल का लॉस होता है, वो हम सब के लिए अच्छा नहीं है। फंड्स की कोई दिक्कत नहीं है, इसमें एक अम्ब्रेला ऑलरेडी बोर्ड ने सैंक्शन कर रखा है। बाकी फर्दर और भी आप कहेंगे तो और भी बेसिकली पैसे मिल जाएंगे इस केस में। तो सेफ्टी फेंसिंग पे मतलब दैट इज फील्ड इंजीनियर्स हैं काम करें, रादर फील्ड इंजीनियर्स काम करें, जो हेडक्वार्टर ऑफिसर्स हैं वो अम्ब्रेला में पैसे सैंक्शन कराना है वो कराएं। और भी कुछ रिक्वायरमेंट है तो हम लोग बोर्ड लेवल पे इसको करने को तैयार हैं, तो इस पे काम करके दें। इन दी लास्ट basically just I want to express my all gratitude to all the participants, speakers and organizers who have contributed to the success of this seminar. Or rather it is not just the technical know-how that basically makes an event like this memorable. It's the shared enthusiasm and shared cooperation, the friendship forged, and the collective vision for a better future. Thank you very much. Thank you.
Thank you so much, sir. Also, midst of us, we have Sri M.K. Gupta, Executive Director, IPWE India, and I request him to kindly give away the vote of thanks for all of us.
बेसिकली एक लास्ट चीज़ और बताना चाहता हूँ कि जो नेक्स्ट सेमिनार IPWE करेंगे, ये वेस्टर्न रेलवे PC has agreed for hosting the next IPWE seminar. वेन्यू टाइमिंग एटसेट्रा वो लोग डिसाइड करेंगे बाद में, बट नेक्स्ट ईयर की वेन्यू इज फिक्स्ड। सो PC वेस्टर्न रेलवे इज डूइंग इट, चूँकि वो अवेलेबल हैं, वो देख रहे हैं, सारा अरेंजमेंट देखा है, सब कुछ देखा है। आशा है इसमें भी कुछ भी और जो भी इम्प्रूवमेंट रहेगा उस इम्प्रूवमेंट के साथ हम लोग नेक्स्ट IPWE सेमिनार में मिलेंगे। थैंक यू।
All right, over to Sri M.K. Gupta, sir.
नमस्कार, श्री V.K. गुप्ता जी, एडिशनल मेंबर सिविल इंजीनियरिंग एवं प्रेसिडेंट IPWE, श्री यादव जी DG एडिशन, IPWE के अन्य अधिकारीगण जो डायस पे बैठे हैं, सीनियर ऑफिसर्स ऑफ सेंट्रल रेलवे, ऑडियंस में बैठे हमारे सीनियर मेंबर्स, एडिशनल मेंबर्स, ऑफिसर्स और दूर दूर से आए हुए डेलीगेट्स, पेपर प्रेजेंटर्स, ट्रेड एंड इंडस्ट्री के लोग और सभी लोग जो यहाँ उपस्थित हैं, मैं आप सभी का बहुत बहुत दिल से धन्यवाद करना चाहता हूँ कि आपने इतनी एंथुजियाज्म से इस सेमिनार में पार्टिसिपेट किया। ये अंतिम क्षण है, पर इसमें मैं एक बात बताना चाहता हूँ, इस सेमिनार का जो श्रेय है वो मैं सही में मायने में अगर किसी को देना चाहे, क्योंकि इसके पीछे जो ब्रेन एक लगता है, जो करने वाले, एग्जीक्यूट करने वाले तो सेंट्रल रेलवे हैं, परंतु उसके पीछे जो ब्रेन है वो पूरा श्री बीके गुप्ता जी का है, क्योंकि इन्होंने जो प्लानिंग गाइडेंस करी है इसी से ये सारा आगे सेंट्रल रेलवे ने बहुत अच्छी तरह ग्राउंड में इम्प्लीमेंट किया है। और सेंट्रल रेलवे भी बहुत बधाई के पात्र हैं जिन्होंने की पूरी जो ऊपर से ब्लूप्रिंट दिया गया उसको जमीन पे वैसे ही उतारा है जैसा उनको गाइड किया गया। श्री यादव जी जो कि इरिसन के डीजी हैं, जितने की पेपर आए बहुत सारा काम था, क्योंकि बहुत सारे पेपर इसमें आए उनको स्टडी करना था, उसमें से बढ़िया से पेपर और अच्छे पेपर्स को यहाँ आपके सामने पेश करना था, वो उन्होंने बखूबी से किया। और जो भी पेपर यहाँ प्रेजेंट हुए उनको देख के ऐसा लगता है कि आई थिंक जितने भी सेमिनार अभी तक रिसेंट मैंने अटेंड किए हैं ये बेस्ट पेपर्स इस सेमिनार में हुए हैं और बहुत ही इंटरेस्टिंग, बहुत ही नॉलेजेबल ये थे और इससे रेलवेज को बहुत ही फ़ायदा होगा। और अंत में मैं सभी का बहुत बहुत धन्यवाद और शुभ शाम, और अभी आप सबका अभिनंदन करते हुए आपको इस सेमिनार का क्लोज करते हैं। धन्यवाद, थैंक यू। नमस्कार।
So, as we come to the close of the seminar, it's time to show our gratitude to all our guests and dignitaries on the dais. I'll request PC Central Railway, the chief host of this function, to please present a memento to Additional Member Civil Engineering Shri B.K. Gupta and President IPWE. Thank you, sir. Next, I'll request PC Central Railway to present memento to Shri R.K. Yadav, our co-host and also Director General Edison. Thank you, sir. Next, PC sir to kindly present memento to Executive Director IPWE, Shri M.K. Gupta, and also the main person of IPWE who has been with us throughout this preparation. And I'll request PC sir to present memento to Shri VP Singh, General Secretary IPWE India, Principal Chief Engineer Northern Railway. PC sir to kindly present memento to Shri R.K. Goyal, Vice President IPWE India and PED Bridges Railway Board. PC sir may kindly get seated. And now finally, time to present memento to the host of this seminar, Principal Chief Engineer Central Railway, and that will be presented by me, Chief Engineer General Central Railway. Said if we use our imagination, the possibilities are limitless. With these words, I thank all the guests, and with this, with the permission of Additional Member Civil Engineering, we declare this seminar as closed.